So, good morning, everyone. So, next topic is orthogonal trajectories. Okay. So, we have seen analytic functions, CR equations, analytic functions, f dash of z, how to calculate f of z by using Milne-Thomson method. Then we have seen harmonic functions and how to find the harmonic conjugate. Okay. The next topic, similar procedure again for calculating the orthogonal trajectory. So before proceeding to problems, now what do you mean by orthogonal? What is the meaning of orthogonal? Orthogonal curves. Do you remember this? The word orthogonal means what? Anybody? Perpendicular. Yes, very good. So orthogonal means perpendicular. So here we are going to find one curve will be given. We are going to find a perpendicular curve which is a curve which is orthogonal to the given curve. That is going to be the topic in this in today's orthogonal trajectory. Okay, so the definition is orthogonal trajectories are a family of curves in the plane that intersects a given family of curves at right angles. Okay, so you have two types of curves and the point of intersection will be at 90 degrees. So whatever intersection points are there, suppose for example, suppose you have a circle. You have a circle with center at the origin. You have family of circles. You have many circles with center at the origin and radius equal to different. And then you have a straight lines which are passing through the origin, that is y is equal to mx form. So here at each point of intersection, we can see that the angle is 90 degree, or each each curve intersects or each straight line intersects the circle at 90 degree. Okay, so that these two curves are called as orthogonal curves. So they intersect at each they intersect at right angles at each point of intersection. So here in this whole chapter, in this whole topic, what we are going to do is we'll be given one curve. We have to find another curve which intersects at right angles to that particular curve. Okay. So now here we have a theorem. That theorem is not taken here. So actually we have a theorem. If f of z is analytic, then the curves u and v intersect orthogonally. Okay. So we are having a theorem. If f of z is analytic, then the curve u equal to c1 and v equal to c2 intersects orthogonally. So that is why the first problem, find the orthogonal trajectory of family of curves. You're given one curve. You have to find a curve which is perpendicular to this particular curve. So find the orthogonal trajectory of family of curves 3x square y minus y cube equal to c. The same way what we have done for finding the analytic function and the harmonic conjugate or v, the same procedure we have to follow to calculate the orthogonal trajectory. Okay, so what we will do is, let us assume that u is equal to the given curve. Okay, if you are assuming u to be the given curve, then we have to find v. If you are assuming v to be the given curve, then you have to calculate u. That is going to be the procedure. So we will assume the given curve to be equal to u. Our aim is to find v. Okay. So what we have to do is again the same procedure for calculating f of z. To calculate f of z, we require f dash of z. And then from f of z, we replace z by x plus iy to calculate the v function. The same procedure what we have done yesterday. The same method is also used to calculate the orthogonal trajectory. तो फिर से यहाँ पे एक कर्व दिया हुआ है. We are assuming that curve is equal to u. We'll calculate ux, differentiating u partially with respect to x. That will be 6xy. Again putting x is equal to z. जो हमने अभी तक किया है वही procedure follow करना है और v निकालना. Nothing new. Put x is equal to z, y equal to 0. And when I put x is equal to z, y equal to 0, we will get ux is equal to 0. Then calculating uy. Okay, same procedure, कुछ change नहीं है इसमें. Only thing, we are not given u or v. We are assuming that let it be equal to u, and then we are calculating v. If you assume this to be v, then calculate u. So both are orthogonal trajectories to each other. तो अगर uy हो गया, now 3x square minus 3y square. Again put x is equal to z, y equal to 0. So we will get uy is equal to 3z square. Okay? Everything is same. तो हार्मोनिक कॉन्जुगेट निकालना है या ऑर्थोगोनल ट्रैजेक्टरी निकालना है, द मेथड रिमेन्स द सेम. uy, देन एक बार ux uy निकल गया, व्हाट डू? वी कैलकुलेट f dash of z. Okay, be the real part. Let u be equal to the left hand side of the curve. Then calculating ux, putting x is equal to z, y equal to 0. Then calculating uy, putting x is equal to z and y equal to 0. Z, ux plus I vx. Since vx is not known, we are using CR equations and calculating and replacing vx by minus uy. So we will get f dash of z is ux minus I into uy. Substituting for ux and uy. ux is 0, uy is 3z square. Integrating and calculating f of z. F dash of z is minus I 3z square. Minus 3i is a constant. So integration of z square will become z cube by 3 plus c. 3 and 3 will get cancelled. So we will get I minus I z cube. So normally we assume c to be equal to 0 in calculating the function v. Now calculate, putting z is equal to x plus iy. Putting z is equal to x plus iy. So minus I into x plus iy the whole cube. Collecting the real and imaginary parts on the right hand side will give you u function and the imaginary part will be the v function. So the orthogonal trajectory will be the v function. तो हमें इसको expand करना है x plus iy the whole cube, a plus b the whole cube. So a plus b the whole cube expansion is a cube plus 3a square b, or you can write Pascal's triangle and write the formula. A plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. So I've written that a cube plus 3a square b plus 3ab square plus b cube. After expanding x plus iy the whole cube, collecting real and imaginary part. So first I'm simplifying inside the bracket, or you can take directly minus I inside. I have simplified here. So minus I into x cube will be minus I x cube. Now here minus I into I. So minus I into I will become minus I square. Minus I square is plus 1. So plus 3x square y plus. यहाँ पे हो जाता है I square. I square is minus 1 into minus I. That is plus I. Here we will get I cube. I cube into minus I. That is minus I raised to 4. I raised to 4 is 1. So we will get this minus sign will be minus y cube. ठीक है? So we are just expanding a plus b the whole cube, simplifying for I powers or I square I cube, taking minus I inside and collecting the real and imaginary part. So the real part will be 3x square y minus y cube. Sorry, 2 plus signs have come here. Plus I into 3xy square minus x cube. So this was the given function, I think. U is equal to this. So the orthogonal trajectory will be 3xy square minus x cube. We can check also. Suppose if I take this equation as equal to C1, then you differentiate, calculate the slope. How do we calculate the slope normally for any curve, which you have done in 10th or 12th? I don't remember where you have done. How do we calculate the slope when a curve is given or when an equation is given? What is the procedure to calculate the slope? Anybody remembers? कैसे हम निकालते हैं स्लोप? अगर एक इक्वेशन दिया है तो स्लोप कैसे निकालते हैं? डेरिवेटिव, करेक्ट. दैट इज dy by dx निकालना है हमको, करेक्ट. तो इफ आई कैलकुलेट dy by dx for this curve, dy by dx for this curve, and then multiply m1 m2 should be equal to what? Product of their slope should be equal to what is the, when do we say that these functions, these two curves are orthogonal? -1. Yes. अगर हम इसको c1 लेंगे, इसको डिफरेंशिएट करेंगे तो dy by dx मिलेगा, इसको डिफरेंशिएट करेंगे तो dy by dx मिलेगा. The slope of first one will be m1, this is m2, and if I multiply m1 m2 it's going to be -1. That I will show you in the last problem. ठीक है, फिलहाल I'm not showing you. It is, so whatever is the V curve, you can check, I'm saying, you can check that part. I cube is where, which part you're telling? The last term, right? I cube is minus I. Now minus I into minus I. What will happen? I cube is minus I and already it is minus I outside. So you will have I cube is minus I into minus I will be plus I square. But I square is -1. ठीक है यश? I cube is minus I multiplied by I. Yeah, minus I multiplied by minus I. That will become minus I plus I square. But plus I square is again -1. Either you take minus I as it is or you simplify this part first. I cube की वैल्यू हो जाएगी minus I. ठीक है, माइनस आई को हमें माइनस आई से मल्टीप्लाई करना है, तो माइनस आई इंटू माइनस आई विल बिकम प्लस आई स्क्वायर. तो आई स्क्वायर इज -1. दैट इज व्हाई वी हैव अ माइनस साइन. क्लियर? Okay, so now the V part, since we have taken the given curve as U, the orthogonal trajectory will become V, or the imaginary part will be taken as the orthogonal trajectory to the given curve. Okay, this is another way of calculating. Till now we used to know that if two curves are given, how to show that they are orthogonal. Now we are given one curve, we have to find a curve which is perpendicular to this curve. Okay, so for that we are going to apply this analytic function procedure to calculate the orthogonal trajectory, or to find the orthogonal curve which is perpendicular to the curve, to the given curve. Okay, the same procedure. I told you that Milne-Thomson method is almost applied everywhere. In all the problems we have this Milne-Thomson method. Find the analytic function, put z is equal to x plus iy, and then calculate the real and imaginary part. Real part will be the given function, imaginary part will be the answer. अगर हमने इसको v लिया है स्टार्टिंग में, तो u will be the orthogonal trajectory. Any doubt in this? Okay, so we'll go to the next one. Complex is not, it's almost dealing with the same topic. हो ज़्यादा कुछ difference नहीं है यहाँ पे. Second one, take this curve, find the orthogonal weight. Okay. Shall I to the next previous slide then? Slide number 6. Okay. So next problem. E raised to x cos y minus xy equal to c. मैंने हर जगह u लेके ही किया है. So now again let u be equal to e raised to x cos y minus xy. Calculate ux, put x is equal to z, y equal to 0, calculating uy, putting x is equal to z, y equal to 0. Then substituting in f dash of z, integrating f of z and putting z is equal to x plus I. So what is ux? ux, e raised to x is the variable, cos y is the constant. तो ux हो जाएगा e raised to x cos y minus x का derivative 1, y will remain as it is. Put x is equal to z, y equal to 0. ux of z comma 0 is e raised to z. In a similar way, calculate uy. Differentiate u partially with respect to y. Differentiating u partially with respect to y. So uy is equal to minus e raised to minus x sin y minus x. u को y से डिफरेंशिएट करना है, तो e raised to x will remain as a constant, cos y का minus sin y, minus y का डेरिवेटिव 1 तो minus x. Putting x is equal to z, y equal to 0. Putting x is equal to z, y equal to 0. So what is uy then? When x is z and y is 0, sin y is 0. So we will get e raised to, that is first term is 0 minus z. ux is e raised to z, uy is minus z. Substituting everything in f dash of z, ux plus ivx. Since Vx is not known, we are going to use CR equations and convert Vx to minus I minus Uy. Substitute for Ux and Uy and integrate y. That is the method. Okay. That is the method in Milne-Thomson method. They have found a method to find, there are different methods of calculating the analytic function. Okay. So y is that x is equal, that is a method they have found out to calculate the analytic function in an easier manner. You have a theory behind that. That's a research done by Milne-Thomson to calculate the analytic function f of z. Okay, that is why they have found that when I put x is equal to z, y equal to 0, we get, otherwise we can calculate by using even exact differential method. There are 4 methods of calculating the that is not the method. X is equal, it is not that we are doing any, we are substituting any manner. See, we have 4 methods of calculating the analytic function. One is by exact differential, then we have different methods. So here they have found that either we use the by exact differential method or we use other 2 methods. When we put x is equal to z and y equal to 0, it gives the same answer. Okay, so we cannot change that substitution. So the research they have found that when I put x is equal to 0 and y equal to z, it is not going to give the same answer as the same analytic function. This is simplest method, so I have taken this method for the explanation part. Okay. That research is there. That research paper is there on this. This Milne-Thomson has done a research on calculating the analytic function. Okay. So f dash of z is ux minus I into uy. Again, substituting for ux, uy. So we will get f dash of z to be e raised to z plus I into z, right? Ux is e raised to z and uy is minus z. So since uy has minus sign over here, this minus z will become plus z. So we will get e raised to z plus I into z. Integrating that, e raised to z integration is e raised to z and z integration is z square by 2 plus c. Again, putting z is equal to x plus iy to find the function v, or to find the imaginary part, which will be the orthogonal trajectory. So put z is equal to x plus iy. So we will get e raised to x plus iy plus I into x plus iy the whole square by 2. Again, normally we take c to be equal to 0. Okay, e raised to x plus x square e raised to x sine y plus half of x square plus y square. Okay, let's check that. So now we have to get the real and imaginary part. So I told you yesterday also, to separate real and imaginary part for e raised to x plus iy, we write this as e raised to x into e raised to iy. And here we have to expand a plus b the whole square. So e raised to x into e raised to iy plus I by 2 into expanding a plus b the whole square. So x square 2ixy minus y square. Again, so we have got the real and imaginary part for the second term. If you multiply by I, we will get the real and imaginary part. But to get the real and imaginary part for this, what do? E raised to x is a real number. E raised to iy is a complex number. So we can write e raised to iy as cos y plus I sin y, because e raised to I theta is cos theta plus I sin theta. We will write e raised to iy as cos y plus I sin y plus I by 2 into x square minus y square. I've taken the real part first and then the imaginary part. So this I by 2 is multiplied to both. Again, one more bracket this bracket has to be here actually. No, I've taken inside. Okay, I've taken inside. Yeah. So actually, the real part is x square minus y square multiplied by I by 2. And then I by 2 multiplied by 2yxy. So again, I square will become minus 2 and 2 will get cancelled. We will get minus xy. So the real part will be e raised to x cos y minus, plus I've just expanded this, e raised to x cos y, I into e raised to x sin y, I by 2 into this minus xy. So the real part is e raised to x cos y minus xy. And if I take I common, e raised to x sin y plus half into x square plus sin square minus y square. Okay, Tejas, you are meaning that e raised to x into sin y you have written, right? E raised to x. Okay. You have missed out that sin y. Plus is not there, no? मतलब you are multiplying that e raised to x, correct, right, someone. E raised to x sin y plus half into x square minus y square, yes. So the orthogonal trajectory will be the imaginary part, which is equal to e raised to x sin y plus half into x square minus y square equal to c. This is important, how to separate real and imaginary part for e raised to x plus iy. Yesterday we have seen log also, log of x plus iy, e raised to x plus iy. And in the beginning, we have done sine of x plus iy, sine hyperbolic, cos, etc. How to get the real and imaginary parts. Next problem. Try this: x square minus y square minus 2xy plus 2x minus 3y equal to c. Ma'am, the methodology is same and by different names. Different names matlab? This is again, see, there are so many instances where you have to calculate a perpendicular curve. One second, previous slide. Now, orthogonal trajectory, it is a separate topic. Okay, if you want to find a curve which is perpendicular to the given curve. So we can apply the same method to calculate the orthogonal trajectory. Same method can be applied to calculate the analytic function. The method is the same, but the concepts are different. Orthogonal trajectories, you want to find two different curves. Okay, method is same. So they have found that this method is useful in calculating the orthogonal curve also. It is useful in calculating the analytic function. Is it done, Disha? So many methods are there, but then I have taken only a single method so that there is no confusion in calculating that. Different books have different methods of calculating, but I feel this is the easiest method of finding the analytic function, orthogonal trajectory. Okay, so I'll go to the next. Try this and tell me what is the ux, uy at z comma 0. Simple problem, again a algebraic equation. Try this and just write ux, uy in the chat box, all of you. Calculate ux. What is ux at the point z comma 0? ux मतलब इसको x से differentiate करना है, keeping y as a constant. Differentiating, or we'll take the given equation as u. 2z plus 2, okay. 2z plus 2, okay. Okay, so what is ux then? Ux is 2x. Derivative of x square is 2x, y square is constant, minus 2xy will become minus 2y. This is again a constant, minus, this is 2. 3y is a constant. So when I put x is equal to z, y equal to 0, we'll get ux is equal to 2z plus 2. Right. Similarly, uy, it's a simple problem. Uy is equal to differentiating u partially with respect to y. Yes. Minus 2z minus 3, right? Putting x is equal to z, y equal to 0, minus 2z minus 3. Substitute everything in the f dash of z function. So f dash of z will become ux plus ivx, replacing vx by minus uy, as vx is not known to us. Substituting for ux and uy. So ux is 2z plus 2 and uy is minus 2z minus 3. And already you have a minus sign over here. So we will get plus 2z plus 3. previous slide. Rugved, you enter, this is through your mail ID, okay? Don't, there's a confusion in marking the attendance also. Okay, Rugved. So next time when you enter, you just, because it's a confusion, who's that Rutuja? There's no Rutuja in the class, right? So it's better that you enter through your mail ID so that we can mark your attendance easily. Okay. So integrating f dash of z. Done with the slide. Okay. So next slide. F dash of z, 2z plus 2 plus I into 2z plus 3. Integrating. Integrate each term because we are having plus sign in between. We can integrate term by term. The first 2z integration is z squared by 2. 2 integration is 2z. 2z squared by 2 and 3z. Integrating and putting z is equal to x plus iy. Putting z is equal to x plus iy. I've simplified here. 2 and 2 gets cancelled. This also gets cancelled. Is it done? Previous one, x square plus 2y minus y square plus 3x plus 2y. Okay, let's check that. Put z is equal to x plus iy. We will have x plus iy the whole square, 2 into x plus iy plus I into x plus iy the whole square plus 3 into x plus iy. Expand the whole function and get the real part and imaginary part. Real part should be a given function and imaginary part will be the orthogonal trajectory. पूरा expand करना है, a plus b the whole square, I को भी अंदर लेना है और पूरे real and imaginary part को separate करना है. तो a plus b the whole square. तो इसको मैंने expand किया तो a square 2ab plus b square 2x 2iy. I को मैंने पहले बाहर रखा है, इसको expand किया है. And then I've taken I also inside. Any way you simplify according to your convenience. 2xy plus 2y plus x square minus y square plus 3y. Tejas has got 3x. And Vidya has got 3y. Let's see. So if I take I inside, I will get x square 2ixy minus y square 2x 2iy ix square. I into I is I square, which is minus 1 2xi. Minus I into 1 is minus I y square 3ix, again minus 3y. Now collect the real part. Real part मतलब बिना I वाले term. तो x square minus y square plus 2x square minus y square plus 2x minus 2xy minus 3y plus I into 2xy plus 2y plus x square minus y square plus 3x. थ्री एक्स ही आ रहा है ना. एक्स स्क्वायर का टर्म है माइनस वाई स्क्वायर है प्लस 2y प्लस 3x. Yes. I think you must have typed it wrong, I feel. क्योंकि दोनों जगह 2y आ गया है. 2y और 3y दोनों जगह पे है. तो I think it must be 3x. Yeah. So the orthogonal trajectory is 2xy plus 2y plus x square minus y square plus 3x equal to c. Yes, Rugved, good. Even earlier we used to have Kanchan Chavan, so like it was Ayush Chavan, but still there was a confusion here. So always enter with your name so that there is no confusion. Okay, so next problem. One more problem, and then the last one with the help of slope will do it. Same way, u is equal to, again as I told you, we have done many problems of similar type. So let u be equal to this. Again, I'll take this as first term. Second term is the bracket term, applying u into v. So ux is equal to first term u into derivative of the bracket term, which is sine y. This is a constant, so it's 0. Then bracket term into derivative of e raised to minus 6, which is minus e raised to minus 6. Put x is equal to z, y equal to 0. When x is z, sines, that is y is 0, sine y 0, sine y 0, y is 0. So the whole term ux will become 0. Then calculating uy. Now in uy, if I see the first, that is e raised to minus x is a constant. So in differentiating only the bracket term. So x into sine y, derivative is x into cos y cos y, both are functions of y. So u into v, y into derivative of cos y, which is minus sine y. So it becomes plus, and then cos y into derivative of y, that is 1. Putting x is equal to z, y equal to 0. So that uy becomes e raised to minus z, cos 0 is 1, so z minus 1, this term is 0. Substitute everything in f dash of z. You can open the bracket and differentiate, nothing wrong in it. I don't do it. I normally take the bracket term as one function and then apply u into v. Or if you feel that, you can take e raised to minus x inside and then simplify. It's up to you. Derivative has to be correct. That is really important. Substituting in f dash of z. Same steps. So minus I e raised to minus z into z minus 1. Integrating. Minus I is a constant which can be taken out. Now integration of e raised to minus z into z minus 1. So how to integrate that? I've already written that. E raised to minus z into z minus 1. It's u into v, or integration by parts. Which one is u? Minus I is the constant which can be taken outside the integration sign. So we have two functions of z, which is e raised to minus z and z minus 1. So z minus 1 u ho jayega, v will be e raised to minus z, L-I-A-T-E. Exponential function comes in the end. Okay. So now integration by parts. So u equal to this, v equal to this. तो मैं याद है मैंने कैसे बताया था कैसे इंटीग्रेट करना है. What is the first term we write? U integral v. सबसे पहले हम, क्योंकि we have u as an algebraic function, we can apply integration by parts directly. तो सबसे पहले हमें लिखना है u integral v. तो u is z minus 1 into integral of e raised to minus z, which is minus e raised to minus z, minus derivative of z minus 1, which is 1, and integration of this bracket term will be e raised to minus z. Okay, this is the generalized rule of uv, and this is applied when we have an algebraic function. Till the derivative of u becomes 0, continue the same procedure. So u integral v minus derivative of u, go on differentiating the u function and integrating the integral v function. Open the bracket, simplify, and write final f of z. So if we take e raised to minus z common, I'll get minus z plus 1 minus 1. 1 and minus 1 gets cancelled. So I will get minus z into minus I. That becomes plus iz e raised to minus z plus c. Okay, then putting z is equal to x plus iy. In second term, it will be minus e raised to minus z. 1 second. Second term is here. Slide number 30, this part you're telling, right? But here, see, first part is u. This is integral of v. The first term in integration by parts is u integral v. So I've written u here and integration of this v, which is minus e raised to minus z. Then the second sign is minus by formula only. Then z minus 1 का derivative is 1. इसका इंटीग्रेशन माइनस ई रेज टू माइनस जेड का इंटीग्रेशन हो जाएगा प्लस और एक माइनस साइन आ जाएगा तो यू विल गेट प्लस ओवर हियर. ठीक है, जेड यू इंटेग्रल वी माइनस इसका डेरिवेटिव यहां पे लिखना है और ये ब्रैकेट टर्म का इंटीग्रेशन यहां पे लिखना है. तो अगर इसको और एक बार इंटीग्रेट करेंगे तो वन मोर माइनस साइन विल कम हियर. सो दैट इज व्हाई दिस टर्म बिकम्स पॉजिटिव हियर. ठीक है, ओके. तो माइनस आई इंटू u integral v minus derivative of u integral of integral v. Then I'm taking e raised to minus z common. So that 1 and minus 1 gets cancelled. The answer is f of z equal to iz e raised to minus z plus c. That is why I always write in bracket. u को अलग लिखती हूँ मैं ब्रैकेट में और इंटीग्रल v को ब्रैकेट में लिखती हूँ ताकि कैसे सेकेंड साइन इज नेगेटिव, फिर इसका डेरिवेटिव, इसका इंटीग्रेशन, थर्ड साइन इज पॉजिटिव, थर्ड टर्म का साइन पॉजिटिव है, इसका डेरिवेटिव, इसका इंटीग्रेशन. I don't adjust that minus and plus sign. I normally do it with the help of bracket, bracket, bracket. Put z is equal to x plus iy. So I into x plus iy into e raised to minus of x plus iy. Again same way as in the previous problem, e raised to को हमें separate करना है So I'll take minus sign inside. So I'll get e raised to minus x into e raised to minus iy. E raised to minus x is a real number. E raised to minus iy will become e raised to I theta is cos theta plus I sin theta, and e raised to minus I theta is cos theta minus I sin theta. This I've taken I inside, so ix minus y. E raised to minus x is real, cos y minus I sin y. Now e raised to minus x is real, which can be written separately. Now, okay, I've taken inside e raised to minus x cos y minus I. Now you have two complex numbers. Multiplicate product of two complex numbers. So when will we get a real part when we multiply two complex numbers? हमारे पास दो कॉम्प्लेक्स नंबर्स हैं, ओके अगर हमें दोनों को मल्टीप्लाई करना है तो रियल इंटू रियल इज अ रियल नंबर, इमेजिनरी इंटू इमेजिनरी इज अ रियल नंबर, है ना, क्योंकि आई इंटू आई स्क्वायर हो जाता है. तो व्हेन यू हैव प्रोडक्ट ऑफ टू कॉम्प्लेक्स नंबर्स, रियल इंटू रियल, तो पहले मैंने लिखा है रियल इंटू रियल, देन लिखा है इमेजिनरी इंटू इमेजिनरी, दैट विल बिकम द रियल पार्ट ऑफ द होल फंक्शन, प्लस रियल इंटू इमेजिनरी प्लस इमेजिनरी इंटू रियल will give you the imaginary part of that. तो पहला मैंने लिखा है रियल इंटू रियल, इसका रियल पार्ट e रेज टू माइनस एक्स कॉस वाई, इसका रियल पार्ट माइनस वाई, तो ये हो गया. फिर इमेजिनरी इंटू इमेजिनरी, तो x इंटू माइनस आई इंटू प्लस आई, दैट इज माइनस आई स्क्वायर विच इज प्लस वन, तो x इंटू e रेज टू माइनस एक्स साइन वाई. देन इमेजिनरी इंटू रियल और रियल इंटू इमेजिनरी, तो x इंटू दिस एंड देन इमेजिनरी इंटू रियल. So e raised to x into e raised to minus x into x cos y plus sin y plus y sin y. Okay. So the orthogonal trajectory is the imaginary part, e raised to minus x into x cos y plus y sin y. Correct. Equal to C. One more problem we will do. Okay, I've just replaced z by x plus iy, separated real and imaginary parts. For the function f of z equal to z cube, verify that u equal to c1 and v equal to c2 cut orthogonally where c1 and c2, c1 नहीं यहाँ पे c2 आ जाएगा, are constants, and f of z is equal to u plus iv. यहाँ पे फंक्शन दिया है and we have to show that those u and v are orthogonal. अभी तक हमें क्या दिया था, either u was given, we were taking u equal to the given function. यहाँ पे function f of z दिया है and we have to show that u and v cut orthogonally. So we will apply the same method of the slopes. Product of the slope is equal to -1. To calculate the slope, we have to differentiate. So u equal to c1 is the first curve. We will differentiate to get the slope of the first curve. Then v equal to c2, we will differentiate and calculate dy by dx to get the slope of the second curve, and then multiply and show that both the curves are perpendicular to each other. उसके लिए पहले हमें u और v निकालना पड़ेगा. Okay, to show that u and v cut orthogonally, we will show that the product of their slopes of these two curves are -1. तो इसका हम स्लोप निकालेंगे, इसका हम स्लोप निकालेंगे. स्लोप निकालना है मतलब dy by dx निकालना है, तो इसका dy by dx निकालेंगे, इसमें से dy by dx निकालेंगे, दोनों को मल्टीप्लाई करेंगे एंड शो दैट -1. c1 and c2 है यहाँ पे, yes it is c2 not c1. Yes, it is C1 and C2. Just make that correction. It is C1 and C2. तो हमें पहले u and v निकालना है. तो u and v निकालने के लिए हमें फंक्शन दिया हुआ है f of z is equal to z cube. तो कैसे निकालेंगे u and v? f of z equal to z cube. The beginning what we did. कॉम्प्लेक्स नंबर के स्टार्टिंग में हमने कैसे किया था? अगर f of z z cube दिया है तो उसमें से u and v कैसे निकलता है? We replace z by x plus iy and f of z by u plus iv. We replace z by x plus iy and f of z by u plus iv. Okay? So f of z is w, normally we denote it by, and we write this f of z as u plus iv, and this is z cube. Z is x plus iy. ठीक है, इसको अगेन एक्सपैंड करना है. a plus b the whole cube यूज करके a cube plus 3a square b plus 3ab square plus b cube. Normal expansion I've done. Simplified the this one, I part. I square is -1, I cube is minus I. And replace f of z by u plus iv. Okay, normally we denote f of z by u plus iv and z by x plus iy. Now equate real and imaginary part. U is equal to the real part and v is equal to the imaginary part. So equating real and imaginary part. तो u हो जाएगा x cube minus 3xy square and v हो जाएगा 3x square y minus y cube. We've collected the real and imaginary parts. So u equal to x cube minus 3xy square plus I into v will be equal to 3x square. I have written that. Okay. Okay, I've written पहले u लिया है मैंने. तो क्या क्वेश्चन में क्या दिया था? We were given u equal to c1. तो यहाँ से u हो जाता है ये टर्म और v होता है 3x square y minus y cube. We are given that u is equal to c1. तो जो u था उसको हमने c1 पुट किया. This is u. So u equal to c1 मतलब this is equal to c1. Now this is you are having a curve. Now differentiate and calculate dy by dx. मतलब क्या करना है? Normal different. Now it is not a partial differentiation. हमें dy by dx निकालना है या slope निकालना है. तो normally इसको differentiate करना है कि not with respect to x ही आएगा इसमें. Y becomes a dependent variable. Y is a dependent variable. X is an independent variable in that case. तो 3x cube का differential हो जाएगा 3x square. इसमें product rule लगेगा. So -3 into x into y square का derivative है. तो y square into derivative of x यहाँ पे 1 हो जाएगा. -3x into y square का derivative 2y dy by dx. हमें dy by dx निकाल, not the partial derivative. Okay. So when I have to calculate dy by dx, y becomes a dependent variable and x is an independent variable. So differentiation is only with respect to x. है ना? dy by dx मतलब differentiating y with respect to x. Or you can maybe simplify also. Calculate y square and y and then simplify. I have differentiated as it is. Because actually it's an implicit function, but these methods were not there for your first semester syllabus. I'm not using that topic, I'm directly differentiating it. ठीक है, u into v apply किया है, y square का derivative हो जाएगा 2y into derivative of y is dy by dx. Why? Because y is a dependent variable. यहाँ से हमें dy by dx निकालना है. So 3x to y dy by dx will become 3x square minus. इसको मैं दूसरे साइड में ले लूंगी. So dy by dx, I can cancel 3 also throughout. Dy by dx is 3x square minus 3y square upon 6xy. Okay, this is not a partial derivative. हमें जब slope निकालना है तो dy by dx निकालना है. मतलब x का डेरिवेटिव 1 होगा और y का डेरिवेटिव dy by dx होगा. In a similar way, the imaginary part का जो part है, v is equal to c2 it is given. इसको भी हमें differentiate करना है with respect to x. डिफरेंशिएटिंग विथ रिस्पेक्ट टू x अगेन, फिर से यहाँ पे दो टर्म्स हैं, तो 3x square dy by dx plus 3y into derivative of 2x, that x square, that is 2x, तो 6xy हो जाएगा, y क्यूब का डेरिवेटिव 3y square और y का डेरिवेटिव dy by dx equal to 0. Again calculating dy by dx from this expression. Keep dy by dx term on one side and all the other term on the other side. So I've kept dy by dx term on the left hand side and 6xy on the right hand side. Again take dy by dx constant. It's a common term. So dy by dx into 3x square minus 3y square is minus 6xy, or dy by dx is equal to minus 6y upon 3x square minus y square. Now this one, equation 1 is the slope of first equation. Equation 2 is the slope of the second equation. Now if I multiply both, is it equal to minus 1? यहाँ पे अगर हमने देखा दोनों dy by dx को अगर multiply किया, this is the slope of the first equation, this is the slope of the second equation, है ना, minus 1 automatically आ जाता है. So I've just written two more steps here. So m1 is equal to the first term, m2 is equal to the second term, m1, m2 is equal to minus 1. Okay? So in the next step, what I've done is m1, m2 is minus 1. Hence the curves u is equal to, v is equal to intersect of. This part we have already done, m1, m2 wala part. So in this, what we have done is, when one curve is given, how to find an orthogonal curve corresponding to that particular curve. Okay, so with this orthogonal trajectory is over. I've given some practice problems. You can go through that. Try these. Answers are also given. Now we have some miscellaneous type of problems that we have to continue, and with that, I think 2 or 3 lectures I'll be completing complex numbers, complex variables also. So thank you for today. See you tomorrow. Thank you. Previous slide, 1 second. This step is just to show that m1, m2. m1 is the slope of the first curve. Of the first curve dy by dx is taken as m1. Second curve dy by dx is taken as m2. Slope is normally calculated by differentiating. Tan theta, yeah, different dy by dx, there are different ways of calculating the slope.